Over the last 30 million years, members of the mustelid family have undergone specific anatomical changes to exploit rich aquatic environments. Today, otters are highly adapted predators, finally recovering from severe 20th century population collapses, driven by aggressive legal protection and targeted captive breeding. The success of these ongoing recovery efforts relies completely on mapping the strict biological requirements and life cycle constraints of the species. This chart compares adult river otters to show their distinct sexual dimorphism. Males can reach up to 4 feet in length and 30 pounds, while females are noticeably smaller, typically weighing around 16 pounds. Both rely on a specialized dual-layer fur system. Stout guard hairs form a waterproof outer layer, protecting the fine, dense underfur that acts as thermal insulation. Because saltwater rapidly reduces this waterproofing, coastal populations must continuously groom and wash in freshwater pools to survive.
To hunt underwater, they physically modify the shape of their eye lens, making it more spherical to overcome water refraction and hunt by sight in clear conditions. Their eyes and nostrils are positioned high on the skull, allowing them to breathe while submerged. Simultaneously, long muzzle whiskers detect the regular vibrations of a fish's tail beat. These anatomical tools allow them to track and capture prey even in highly murky water, turning a standard carnivore body into a highly efficient aquatic instrument. This map illustrates how resource density dictates territory size. Depending on river productivity, a male river otter might patrol up to 80 kilometers of water. In contrast, coastal otters have an abundant food supply, shrinking their required range to just a few kilometers. While fish are their primary prey, otters are opportunistic. Their diet expands to crabs, water birds, and occasionally land mammals like rabbits and moles. They successfully sustain these territories by prioritizing high-energy prey and actively avoiding areas of human overlap. Breeding timing is strictly synchronized with local climate and food availability. In environments like Sweden, where winter freezes the lakes, cubs are born in spring to ensure they are fully grown before severe weather returns. Mothers secure birthing dens lined with reeds and grass to retain heat. Inland populations usually produce litters of 2 or 3, while coastal otters tend to yield smaller litters. This timeline tracks their strict developmental path. The 700-gram cubs open their eyes at 5 weeks. By week 7, they transition to solid food. They leave the nest at 10 weeks and finally begin swimming after 3 months. Even though cubs hunt independently at 8 months, the mother must aggressively enforce their departure at 9 months to clear the territory for her next breeding cycle. The near extinction of the British otter began in 1955. Agricultural pesticides like dieldrin washed into river systems, bioaccumulating at deadly concentrations as they moved up the food chain, from microorganisms to fish and ultimately to the otters. This graph charts the population collapse. Despite 1962 chemical phase-outs, habitat loss and road deaths drove numbers down into the 1980s. Reintroduction stabilized these networks. In Norfolk, where only 20 animals remained, the Otter Trust released enough individuals to successfully finish its breeding program. Today, the population is expanding naturally. Their long-term viability no longer relies on captive breeding, but on the continued enforcement of environmental laws protecting their waterways.